This video will review the second specimen. Here it's decalcified bone. And so when we open this specimen, you see a very eosinophilic staining ring. And in that, you see a mixture of lightly stained areas and that are non-stained and some basophilic and eosinophilic areas. But in the center here, you have empty space. This is an artifact, an artificial fact. It is a result of the tear of the tissue. So in the center is bone marrow, and around the periphery is compact bone. And this is actually a cross-section of a long bone. And out along the edge is some skeletal muscle, and we'll take a look at that in a moment. So I guess first we'll, in this particular module, you are learning about bone marrow. So let's just take a little higher magnification view of this. And you see a combination of adipose tissue and hematopoietic tissue. Now, these somewhat reddish areas, very light reddish, those are collections of red blood cells that were not fixed very well, so you can't see the individual cells. Many of the small rounded nuclei could be either immature red blood cells or lymphocytes, and occasionally you may see a very large cell, like maybe this one and others, but you can look around in here and try to find megakaryocytes. I'll pause this, but this is not the best specimen to study and look at all the bone marrow cells. Now, in the center here, this is something you haven't studied yet. This is a cross-section of an arteriole within the bone marrow, and surrounding that you have some sinusoid vessels with red blood cells in it, and these little tiny cells here are lymphocytes within the blood vessel. This is smooth muscle. You are studying smooth muscle during this second module, and the smooth muscle is arranged around the lumen of the arteriole, and lining the lumen are simple squamous epithelium, and we know that as endothelium. And out around here would be adventitia. Now those are the endothelium and the smooth muscle in the media and adventitia. That's something you will learn, those terms and those parts of the vessel when you study the cardiovascular system in Module 3. So I'm going to pause this for a moment. Okay, here are two megakaryocytes. Now, this is a maximum magnification here. You see it's 100%, and the scale bar here is 50 micrometers. So these cells are probably about 25 to 30 micrometers in diameter, which is pretty small for a megakaryocyte. If you would like to enlarge this more, if you push the Z key on your computer and then you outline this, it will enlarge it. But you see, that's empty magnification. So that all of here is 5 microns. So that's not that helpful. But sometimes just a slight, say if you make a marquee like this, you get a little bit closer view. But the resolution is not improved. That's why we call it empty magnification. Okay, let me go back out here and let's just look at the compact bone tissue. You are learning about bone tissue and learning about its structure, and you see these structures here that have a little opening where blood vessels go. That's the Haversian canal, and around that you have concentric layers of mineralized bone tissue that is composed of collagen arranged in different angles as each layer is laid upon, and then the osteocytes here. Just to point that out, and then in the side here you have intercircumferential lamella. The arrangement of the osteomes is not obvious here. These are just concentric layers of bone lamella with osteocytes and some blood vessels going through. And then you've got the osteomes, Eversian systems here. And then on the outside, sometimes you will have the outer circumferential lamella. But in this case, the osteomes are going way out. Now, if I magnify this area, there are some osteoblasts, and this is periosteum. You can see the collagen of the periosteum, and then osteogenic cells here, the periosteum, and then the more basophilic cells are osteoblasts. Okay, so the last, and I'm just running slightly over 5 minutes here. The last would be, this is cross-section of skeletal muscle. So in this specimen, you can study bone marrow, compact bone tissue and its components, and skeletal muscle.